In this video, we're going to make a pretty cool graphics program. In particular, this is really going to be drawing on the knowledge of how the variable in the for loop works. Let me show you what we're going to make, and let's actually talk about it a little bit. This is the stacked circles program. This is actually what we're going to be making in this example. Now you might be thinking, oh my gosh, this looks sort of overwhelming, but let's actually break it down. What we're drawing in this is a bunch of circles stacked on top of each other. This is the stacked circles program. Let's actually take a look at the constants we're given in this program with this picture in mind. Here is the stacked circles program, and here actually are the constants that we've got. It looks like I'm given a radius for the circle, which probably should be half the width and half the height, an overall number of rows, and an overall number of columns that I'm going to be working with. Now let's think about what am I actually doing over and over again in this program. We're always thinking top-down design, big picture, what's going on here is that over and over, aren't I actually drawing one single row of circles? And if you think about it, we've actually drawn a row of something before. Remember, a bunch of examples ago, we actually wrote a graphics program called Row of Blocks. This actually isn't going to be all that different. So if I'm doing something over and over again, let's say I'm drawing a row over and over again, how many rows am I drawing? Well, probably num rows. I know how many that is. I'm repeating something a certain number of times, so I want to start with a for loop here. For int I equals 0, I is less than num rows, I plus plus. And now again, what am I doing num rows times? I'm drawing an entire row. Doesn't drawing an entire row also take a for loop? So let's write a for loop here. For int I equals 0, I is less than how many circles are in each row? Isn't it actually the number of columns? So I'm going to put num cols here, I plus plus. You're going to see right off the bat that we're going to have an issue here. Remember back when I said when we first started using this I, that I is a variable that lives inside of the for loop. Well, we know that I can't actually have two variables named exactly the same thing. My computer won't actually know which one I'm referencing. But that's exactly what I've tried to do here. I have the variable in the outer for loop named I, and I just tried to make the variable in the inner for loop also named I. So what do I have to do? What do most people just do is let's change these I's to J's. Make sure you change all three of them. If you leave one of them as an I, it's actually not going to work the way that you want it to. So let's think for a minute about what I and J actually control. Remember, the I for loop is the idea that what am I doing? I'm drawing num rows, full rows of circles. The J for loop is actually which circle am I on within the row. So if you think about it, I controls which row I'm currently drawing. J controls which circle within that row, or you can think about that as which column I'm currently drawing. Take a look at the labels I've added onto the circles. You can see that I corresponds with which row I'm on, and J corresponds with which column I'm on. I've chosen the one in row 2, column 3, and you can see I is 2 and J is 3 for that particular circle. If I only put a line of code inside the I for loop, like let's say I put something here, how many times will this for loop happen is the same as num rows. It should happen 8 times. If I put a line of code inside the J for loop, how many times will this happen? Well, 8 times. Won't this for loop happen 12 times? So this will actually happen 96 times. And if you think about it, there actually are 96 circles on my screen. So in here, it would make sense that I would put the code to draw a circle inside of both for loops. Let's do G oval circle equals new G oval. And this is where this example is a little bit tricky. We said that I is what? I represents which row you're in. Now, this is going to feel a little backwards in your mind, but Are rows the x coordinate or the y coordinate? The way that I want you to think about this is, as I change which row I'm in, am I changing in the x direction or the y direction? As I change rows, I'm actually changing in the y direction. I'm actually moving down the screen, or my y coordinate increases, which means that the y coordinate will actually depend on I. On the other hand, J controls which column I'm in. As I change columns or increase my column, I'm actually increasing my x coordinate. So the x coordinate should depend on J. Now, every time I draw a new circle, let's think about the x coordinate. If I draw a new circle and it's the next one over, I've now gone from circle j equals 0 to circle j equals 1. I've increased my column by 1. Didn't that push my x coordinate over by an extra 2 times radius? And you can see that happening every single time I increase my x coordinate. It gets pushed over by an extra 2 times radius based on which column I'm in, which is j. So I think I'm going to have 2 times radius times j. Let's make this a little bit bigger. Similarly, every time I move down one circle, this is from I equals 0, I equals 1, I equals 2, as I increases, my y coordinate gets pushed down by an extra 2 times radius down. So I'm going to have 2 times radius times I. And then for the width and the height, they're the same for every circle. It's just 2 times radius and 2 times radius. And these aren't filled in or shaded or anything or colored. Let's just add circle. And if we compile this, we should be able to run it. And there we go. There's all of our stacked circles. Now that we're working with rows and columns and kind of I and J, things are getting a little bit more confusing. We're used to thinking of rows as horizontal, but remember, how you want to think about it is as you change rows, what's happening is that I actually change in the up and down direction. And as I change columns, what's happening is I change in the right to left direction or the x direction. We're going to see this idea of rows and columns a lot in this class, but actually not really until next semester. That's when we'll deal with things that belong in grids, things like pictures, maybe spreadsheets and other stuff like that. That's going to actually be the first unit of our spring semester. I want to do one more thing in this program, which is I want you to see kind of how these circles are drawn on. If you had to kind of take your finger and trace across the screen how you think the circles appear, like in what order, go ahead and do that. We can actually add something to our program to see what's happening. Remember, this J loop draws on an entire row. So these should be added on kind of row by row going down. Since this up here is I equals 0, and this down here would be actually I equals 7. Let's go ahead and just add a pause 50 in here, just so we can see how each one of these circles is actually drawn on. And there you go. This is how they get drawn. If we're looking here, right, this makes sense. What am I doing num rows times? I'm drawing out an entire row. So these should get added row by row. We've seen nested if statements before. That's an if statement inside of another if statement. Now, you've seen a nested for loop. All this is a for loop inside of another for loop. These nested for loops sometimes get a little bit tricky. How I want you thinking about this in another way is that every time I increases by 1, every time the outer for loop repeats a single time, the inner for loop has to go all the way through. So when I is 0, J goes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Then J is done. I goes to 1. J goes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And it will keep doing that until I runs out. That's how the nested for loop works. We're going to see a pretty similar example to this next, but instead of circles, we're actually going to be looking at blocks. We're going to do 3 different types of pyramids in the next example.